Welcome to the second session on analog communication practicals. In this section, we will see the demonstration of two practicals. First, SSBSC modulation and demodulation, and second, super heterodyne receiver. Let us start with SSB modulation first. Mathematical expression for SSB modulation theoretically is phi SSB of t equal to modulating signal multiplied by carrier signal plus minus 90-degree phase shifted modulating signal multiplied by 90-degree phase shifted carrier signal. For our experimental board, we can use phi SSB of t equal to modulating signal multiplied by 90-degree phase shifted carrier signal plus minus 90-degree phase shifted modulating signal multiplied by carrier signal. Now, let us see the actual demonstration with the help of SSB modem experimental board. Here we can see the modulating signal generated section on the upper left corner. We can adjust its frequency as well as amplitude with the help of the frequency adjust and amplitude adjust potentiometers. Modulating signal generator section is connected to phase shift network section, which does the 90-degree phase shifting of modulating signal. Thus gives out the 90-degree phase shifted modulating signal indicated by FM plus 90. Similarly, we can have carrier signal and 90-degree phase shifted carrier signal indicated by FC and FC plus 90 respectively. If you adjusted 90-degree phase shift between FM and FM plus 90, then the corresponding 90-degree phase shift between FC and FC plus 90 will get automatically adjusted. Then we have DSBSC generator 1 section in which we'll perform the first multiplication part of the SSB expression. DSBSC generator 2 section will do the second multiplication part of the SSB expression. Finally, adder will do the addition of those two individual multiplication parts. At the output of adder section, we can have SSB modulated signal. SSB demodulator block will perform the synchronous demodulation so as to recover the modulating signal. Now, let us see the actual demonstration. First of all, we will adjust the modulating signal to 3 to 5 kilohertz frequency with the help of the frequency adjust potentiometer. Then we'll have 90-degree phase shifted modulating signal at the output of phase shift network. Now we will indicate the modulating signal as FM and 90-degree phase shifted modulating signal by FM plus 90. Then we can have carrier signal at the output of carrier generator section, and we can have 90-degree phase shifted carrier signal. So both carrier signal and 90-degree phase shifted carrier signal will indicate by FC and FC plus 90. Now before going to the DSBC generation 1 section, first connect modulating signal FM to channel 1 of DSO. Now we'll go towards the DSBC generation 1 section. So you can see DSBC generation 1 section has two inputs. One is modulating signal as it is and 90-degree phase shifted carrier signal. So at the output of DSBC generation 1 section, we can have DSBC 1 signal. So you can observe DSBC 1 signal with respect to the modulating signal. In DSBC 1 signal, you can have two loops in one period of modulating signal. So the amplitudes of those two loops must be same. So if they are not same, you can make them same with the help of this potentiometer. Now let us go towards the DSBC generation 2 section. Again, you can see there are the two inputs to this DSBC generation 2 section. So first input is 90-degree phase shifted modulating signal, and second input is the original carrier signal. Now, once I will connect the 90-degree phase shifted modulating signal and carrier signal to the DSBC generation 2 section, I can see the DSBC 2 signal at the output of DSBC generation 2 section. Again, I can see the DSBC 2 signal with respect to modulating signal. Then next block is adder block, so I can add these two DSBC signals to the input of the adder block, and at the output of adder block I can get the SSB signal. If you want to see the SSB signal clearly, you can observe the SSB signal on the DSO with respect to carrier signal. Then we have to move towards the SSB demodulation block. Here the demodulation which we are going to carry is of synchronous demodulation. So we have to use the same carrier as that we have used at the time of modulation. So we'll connect the SSB signal to the first input of SSB demodulation block, and to the second input I will connect the original carrier signal. So if I'll connect these two inputs to the SSB demodulated block, I will get the required modulating signal. So the probable questions on this experiment is, what is SSB demodulation? What are different methods of SSB generation and detection? And what are the applications of SSB modulation? Now let us move towards the next practical, that is super heterodyne receiver. So this is what is the experimental board for super heterodyne receiver. So here you have to see the 4 important points of the experimental board. So it is a superhead input. So at this point I'm to apply the modulated signal. Second point is the tuning control. So this tuning control I will use to tune my receiver circuit. Third is the volume control. So here I can control the gain of my amplifier, and I can vary the voltage or amplitude of the received signal. And last, this is the point where I will get the actual received signal. Okay. So let us start with the actual demonstration. So you will use here arbitrary function generator, and from this arbitrary function generator I can apply the modulated signal to the input of superhead receiver. So the settings for modulated signal would be 625 kilohertz, frequency 200 millivolt peak to peak, and 30% depth. These are the modulated signal parameters, and 400 hertz frequency is the modulating signal frequency parameter. So this modulated signal will apply to the input of the superhead receiver. Then you will connect the receiver output to the DSO. Then you can adjust it with this tuning control so as to get the maximum output voltage sinusoidal signal on the DSO. Then we will adjust this volume control so as to get 1.78 volt peak to peak voltage on the DSO. Now let us move towards the first characteristics, that is selectivity, vary modulated signal frequency and measure the output voltage on the DSO. So here you can have three readings below 625 kilohertz frequency and 3 readings above 625 kilohertz frequency. We can plot the graph of output voltage on DSO versus modulated signal frequency. Now, before going to the next characteristics, please make sure that you have come back to your original setting of modulated signal as 625 kilohertz, 200 millivolt peak to peak, 30% depth, and 400 hertz modulating signal frequency. Also make sure that the output of sinusoidal signal is having 1.78 volt peak to peak voltage. Once you have come back to original settings, you can go towards the next characteristics. Now the next characteristics is fidelity. So you can see here that is in this fidelity you have to vary modulating signal frequency and you have to measure the output voltage on the DSO. Here also we can have 3 to 4 readings below 400 Hertz and 3 to 4 readings above 400 Hertz frequency, and you can measure the output voltage on the DSO. You can plot the graph of output voltage on DSO versus modulating signal frequency. Again, before going towards the next characteristics, please make sure that you have come back to your original settings of modulated signal at 625 kHz, 200 mV peak to peak, 30% depth, and 400 Hz modulating signal frequency. Also make sure that the output sinusoidal signal is having 1.78 volt peak to peak voltage. Once you come back to the original setting, you can go towards the next characteristics. Now the next characteristic is sensitivity. What is sensitivity? In this sensitivity, you have to vary the modulated signal frequency and adjust the modulated signal voltage so as to get 1.78 volt peak to peak output voltage on the DSO. So while doing the sensitivity characteristics, first where the modulated signal frequency, automatically the output signal voltage will get changed from the original setting, that is 1.78 volt peak to peak. Now we need to bring back this changed output voltage to 1.78 volt peak to peak. To do so, we need to vary the modulated signal voltage, that is we need to change the 200 millivolt peak to peak setting. Now we will change the modulated signal voltage so that the output voltage becomes 1.78 volt peak to peak. Here we have to plot modulated signal voltage versus modulated signal frequency. So in this way you can perform the super heterodyne receiver practical. The important questions for this practical are: explain the diagram of super heterodyne receiver, explain the characteristics of super heterodyne receiver, that is what is sensitivity, what is selectivity, what is fidelity, draw the corresponding graphs of selectivity, sensitivity, fidelity. Okay, these are the questions for the super heterodyne receiver experiment. Thank you.